Hello, I'm Miss Jet, and I'm going to go over the Chapter 12 practice test for geometry. So first one, it says we need to write a rule to describe the transformation. So here, when I look at this image, I notice that, so for example, point C is the same distance from the y-axis as C prime. So also you can notice that there's a symmetry to both of these, the pre-image and the image. So this one is being reflected across the y-axis. So on our answer, there we go, we can click it's being reflected across the y-axis. And that's all you have to put to describe this transformation. For number 2, it says describe the transformation, and there's a hint we need to start with x, y. So when I look at this image and pre-image, it looks like the pre-image, J, I, H, we still have the same order, J prime, I prime, H prime. So it looks like it's just been sliding down and to the left. So that's a translation. So we can write what's happening with the translation if we copy this. So I'm going to go ahead and copy that little X and Y. And then we need to draw a little arrow that means X and Y is going to map to. And then we need to figure out what's happening to X and what's happening to Y. So X, we're just going to pick one point to compare. If we look at the X value for I, it's at 3. But when we look at I prime, it's at 2. So we need to do X minus 1. We can test that out with another point. So we have H here. Again, it's on the X axis, it's only going down 1. Again, J and J prime, again, it's going down 1. So we can say X minus 1, comma. Now we need to figure out what's happening to Y. So Y is the up and down value. So if we're looking at I and I prime, I would be at 1, 2, 3, 4. But then I is at Y equals 0. So maybe it's Y minus 4. Let's try 2 other points. So here we've got J. J is at Y equals 2. And then if we go down 4, J prime would be at negative 2. So it is subtracting 4. So we could say Y minus 4. That's the answer for number 2. Let's go ahead and do number 3 through 7. I know that these problems look very complex because they have lots of problem numbers on it, but it's pretty straightforward. It's just one problem with lots of places to put answers, okay? So it says graph the image of the figure using the transformation given. So the transformation is we're gonna do a rotation of 90 degrees counterclockwise about the origin. Then it says to list the coordinates of the vertices of the new image. So we need to find W prime, X prime, Y prime, and Z prime. There's a little typo here. So I'm going to click on show your work. Again, we need to do a rotation of 90 degrees counterclockwise. I'm going to go ahead and close this window because everything I need is on the show your work. The first thing that you should do is when you see rotation of 90 degrees, you should look up what the rule is for how to rotate 90 degrees using X and Y. So I've put on Google Classroom some resources that you can use during your test or your practice test. Here's the rules for rotation. So again, we're doing rotation of 90 degrees. These rotations automatically go counterclockwise. So if you see something that says counterclockwise, that means normal. We're going kind of from 12 o'clock to 9 o'clock to 6 o'clock to 3 o'clock. So we need to use this rule to do a rotation of 90 degrees. So I'm going to try and copy and paste it, maybe. There we go. And then I'm going to go back to my Go Formative, and I'm going to paste the rule in there so we can follow it. So there's our rule. So we need to take that X and Y, and we need to flip them, and then we need to make the Y value the opposite sign, okay? So our first step is to find out what are the vertices, what are the coordinates of our pre-image. So I'm going to write them to the left of w prime, x prime, y prime, z prime. So w is at the coordinates -1 and then up 1. So -1, 1. Let's go ahead and do x prime. So x is at -1, 2, 3. So -3. And then we have to go up 1, 2, 3, 4. Y prime, or sorry, y would be at -3 and then up to 5. And then z would be -1, but then up 1, 2, 3, 4, 5. Move some of these over. There we go. Okay, so now that we have our coordinates for the pre-image, we can do this flip, so our swap, and then change the sign of y. Use a new color. Oh, whoops. There we go. So for w prime, we need to swap these. So if we swap them, we'd have 1, and then for the y value, we'd have -1. But we need to change our original y value to be the opposite sign. So instead of positive, it's going to be negative. So w prime would be -1, -1. For x prime, again, we swap, we flip them. So 4, -3, but then we need to flip the sign of +4. So now it's going to be -4, -3. For y prime, it would be 5 and -3. But again, we need to swap the sign of our y. So it's going to be -5, -3. And for z, again, we have 5, -1. But instead of +5, we need to make it a -5. Okay, so let's go ahead and plot those points. I'm going to make this a little bit bigger. So we need to go to -1, -1. So -1, -1, put a dot. And that's going to be w. And then -4, -3. So 1, 2, 3, 4, and then down 3. 1, 2, 3. That's going to be x prime. -5, -3. So I got to go back 5. 1, 2, 3, 4. Whoops. 1, 2, 3, 4, 5. And then go down 3. So 1, 2, 3. That's going to be y prime. I'm going to move my x prime label. There we go. And then last one is z prime. So that's at -5 and then -1. So it'd be right here. And that would be z prime. After that, you can use the line tool to make your shape. So here we go. So z prime to w prime to x prime to y prime to z prime. Cool. So that's going to be our rotation of 90 degrees counterclockwise. I'm going to close this right here because I did what I was supposed to. I graphed my new image. And then now I need to input my coordinate points for each one. So w prime we decided was -1, -1. X prime we decided was -4, -3. Y prime, again, I'm just looking right up here and copying it down. Let's see. Oops, this, I think there's a typo. W, X, so this must be Y and then Z. It's a little bit messed up. I'll make sure to change it. I'm sorry for those typos. Okay, so let's see, -5, -3. Then the last one would be -5, -1. Oop. Nope, that did not paste. Okay. So we had, what was it, -5, comma, -1. There we go. Okay. So that's it for numbers 3 through 7. Let's do the next one. It says graph the image of the figure using the transformation given, list the coordinates of the vertices of the new image. So we're going to be doing a reflection across the line y equals x. So I'm going to go ahead and click show your work, close this, and then I need to look up how am I going to do a reflection across the line y equals x. So I'm going to go back into this document and go back up, and here's the rules for reflections. So here's for across the x-axis, here's for across the y-axis, but we're going to use the one where we need to do across the line y equals x. So we're going to take x, y, and we're just going to flip them, swap them to y comma x. So let's zoom out a little bit. Let's go ahead and write down our rule. So we're going to do x comma y, and that's going to map to, or that's going to change where we go y comma x. The first step is you should be writing down the pre-image points before you write down your image points. So I'm going to go ahead and move this over so we can write down some points. So first one, let's find out where G is. G is at -1, +1. So -1, +1. H is at -1, 2, 3, so -3. And then you got to go up 1, 2, 3, 4. I is at -1, 2, 3, 4. And then we got to go up 4. And then J, last one, is at -1, 2, 3, 4, 5, so -5. And then 0. Okay, so all we need to do is flip our x and y values and write them here. So I'm going to change my color. Okay, so for G prime, instead of -1, 1, it's just going to be 1, comma, -1. For H prime, instead of -3, 4, it's going to be 4, -3. For I prime, instead of -4, 4, it's going to be 4, -4. Last one for J prime, instead of -5, 0, it's going to be 0, -5. Okay, so let's go ahead and plot these points. I'm going to use my scribble tool. So we need to go to 1, -1. So 1, -1. My dot's kind of tiny. Let's go ahead and do bigger size dot. There we go, cool. After that, we need to do 4, -3. So I go over 1, 2, 3, 4, and then I go down 3, 1, 2, 3. Next one, 4, -4. So 1, 2, 3, 4, and then down 1, 2, 3, 4. And then 0, -5. So I'm at 0, and then I got to go down to -5. 1, 2, 3, 4, 5. I'm going to go ahead and label these real quick. So this is going to be my G prime. This one is going to be H prime. This one is I prime. And this one's J prime. Okay, and then use the line tool, connect the dots. All right, there we go. I kind of moved my head a little bit because, again, we're trying to reflect across the line that looks like this. So there's an invisible line right here, and we have to see, okay, is that symmetrical? Did we do it correctly? And yeah, it looks symmetrical. Okay. That's it for this one. Let's go ahead and enter our coordinate points into GoFormative. So for G prime, we decided it was going to be 1, -1. There we go, 1, negative 1. Next one's going to be 4, negative 3. Next one's going to be 4, negative 4. And the last one's going to be 0, negative 5. Whoops, 4, negative 4. And 0, negative 5. All right, there we go. That's it for reflection across the line y equals x. Let's do our next one. It says graph the image of the figure using the transformation given. So we're going to do a translation, which means we're going to do a slide. So I'm going to go ahead and click show your work. Close this. So for these translations, it has the directions, it has the mapping for you. So you don't need to look up the reflection or rotation. So again, first step is let's figure out what our coordinate points are for the pre-image. So I'm going to zoom out real quick. Okay. So let's figure out what our coordinate points are. So for I, make it a little bit bigger. Okay, so for I, it looks like we're at negative 1, 2, 3, 4. So I'm going to do 4, comma 0. For J is right over there, so negative 1, 2, and then up 1, 2, 3, 4. So negative 2, comma 4. Next one, K is at 0, and then up 2. And last one, L is at negative 1, 2, 3. And then down 1, so negative 1. Okay, so for these points, our new points, I prime, J prime, K prime, L prime, we need to do x plus 1. So our x values are right here. So we need to add 1 to all of those. And then for our y values, we need to subtract 4 from all of those. There we go. Okay, so for I prime, make it just a little bigger. There we go. So 4 plus 1 is going to be 5. And then 0 minus 4 would be negative 4. For J prime, we need to do negative 2 plus 1. Well, negative 2 plus 1 is still going to be negative 1. And then 4 minus 4 would get us 0. For K prime, 0 plus 1 would give us 1. And 2 minus 4, kind of a tricky one, 2 minus 4 would give us negative 2. Last one, we need to do negative 3 plus 1, so that gets less negative, so we get negative 2. And then negative 1 minus 4 would give us negative 5. So those are our points. I'm going to go ahead and graph these. Another way that you could have done this transformation or translation is take your x values and move them to the right one. So K would be here. So take the point K, so move it right 1 and then go down 4. So 1, 2, 3, 4. And if you notice, our point for K, we said was 1, negative 2, and that's, we moved it to 1, negative 2. So you can do it either way. You can plot the original points and then do the math, or if you just want to follow the rule that we need to go right 1, down 4, that'll work too. Again, it just depends on how comfortable you are with using this. So I'm just going to go ahead and plot the points. So I is going to be 5, negative 4. Again, we're going to the to the right 1 and down 4. Right? Oh, I need to be at positive 5. That's why. So 5 and then negative 4. So down 1, 2, 3, 4. Where is I? Here we go. x plus 1 down I figure out what I did. I did not plot my original point correctly. I put +4 instead of -4. So I need to fix that. So it was -4, 0. So that's going to change our x value right here. So -4 plus 1 would give us -3. I figured out my mistake, which is good because chances are if I made this mistake, maybe you did too. All right, let's erase this dot right here. There we go. So now this makes a little bit more sense because again, we're going to go to the right one and then down 1, 2, 3, 4. And that's at -3, -4. So I fixed my error. Okay, so there's I prime. And we decided that this is K prime. So J prime would be at -1 and then 0. Again, let's test that dot. Again, we're going to the right one and then down 4. So yep, that one works. This one, -2 and then -5. And for L, we're moving right 1 and down 4, so that one works. Let's label them. And this will be L prime. And let's get our line tool, draw some lines. All right, there we go. So, and if you look, again, it just moved to the right one and then down 4. All right, I'm going to click done and then enter in my coordinates. So we've got -3, -4. For J prime, we've got -1, 0. For K prime, we have 1, -2. And then we also have -2, -5. All right, that's it for this problem. Let's go to the next one. All right, so now we're on to dilations. So we're going to graph the image of the figure using transformation given. You list the coordinates of the vertices of the new image. So I'm going to click on show you work. Close this. Remember that a dilation means that we are either magnifying an image, so making it bigger, taking each point and multiplying it by a certain number, or if it's a number that's less than 1, it means that we're shrinking that image, we're making it smaller. So we need to take our original pre-image coordinates and multiply all of them by 1/2. So again, first step, I'm just going to write down what the original coordinates are. So let's go ahead and look at V. So V is at +2, -1, 2, 3, 4. So 2, -4. W is at 2, 0. X is at 1, 2, 3, 4, 5, 0. And then last one, Y. Y is at 1, 2, 3, 4, -4. Okay. So for this rule, we need to multiply each of them by 1/2. So if we were going to write out like our plan of what we're going to do, I'll write it right up here. So we need to take X and Y, and we need to change it so that it's 1/2 times X, and then 1/2 times Y. Or you could also write it like this, 0.5, so a decimal, and then 0.5 for Y. Let me move that over. There we go. So you could either use the fraction way or you can write it out as a decimal, but we need to cut our x values in half and cut our y values in half. All right, so let's see, 1, 2, 3, 4. Yep, x is right. Okay, so let's go ahead and do that. 2 times 0.5, or 2 divided by 2, is going to give us 1. So 2 cut in half is 1. And then -4 cut in half or multiplied by a half is going to be -2. For w prime, again, 2 divided by 2 is going to give us 1. And 0 divided by 2, well, it's already 0, so it's just going to be 0. 5 divided by 2 is going to give us a decimal number or a fraction. So for this one, 5 divided by 2 is going to be 2.5. And then 0 divided by 2, again, it's still going to be 0. And for the last one, 4 divided by 2, or times a half, is going to be 2. And then -4 divided by 2 is going to be -2. So there's our points. I'm going to go ahead and plot those points. So first one is at 1, -2, so down 1, 2. Okay. Next one is 1, 0, so we got to go 1 and then 0. This one is 2.5, so we got to go up 1, 2, and then between the 2 and the 3. So I'm going to plot that point right in the middle. And then 2, -2, so we go up to 2, and then we go down to -2, and our point is right there. I know it's kind of hard to see. I'm going to go ahead and label my points. So this one was v prime. This, whoops, 1, 0 is going to be w prime. Did I get that right? Oops, this one's w prime. That's why. W prime. This one's v prime. This is going to be our x prime, and this is going to be our y prime. And then we need to connect the dots, connect the vertices. So our line's going to go there, and then to there, and then to there, and then to there. If you wanted to, I know the directions say to shade in your box. You could also do that by using like a highlight tool on GoFormative. So pick a color and then lower your opacity, which means it'll be see-through. And then you can either use the line tool, or I think using the scribble tool would be better. Also, you got to do it all in one kind of coloring session, because if you color twice, it'll make it darker. So awesome, I colored in my shape. Again, if you use that highlight tool, like if you draw one and let go of your mouse, and then you do another one, so if you try and sketch like that, you can kind of see through it and it looks kind of messy. But that's okay. If you don't want to highlight it, again, that's okay. I can see your work, so that's fine. So we're done with that. We graphed our image. Now we need to put in our points. So it's going to be 1, -2. For w prime, it's going to be 1, 0. For the next one, it's going to be 2.5, 0. Oops. There we go. 2.5, 0. The last one is 2, -2. Let's move on to the next one. It says graph the image of the figure using the transformation given. So we're going to do a dilation of 2. So that means for every single point, every single vertice, we need to all right, let's move on to the next one. It says graph the image of the figure using the transformation given. So we're going to be doing a dilation of 2. That means for each point, we're going to be multiplying both x and y by 2. So let's go ahead and click show your work. And I'm going to close that. So first step is let's make a plan for what we're going to do to x and y. We could just type it out so it's easier to remember. Change some of my settings. There we go. So what we're going to do is we're going to take x and y, and for x and y, we're going to change it so that it's 2 times whatever the x value is and 2 times whatever the y value is. So let's go ahead and figure out what these coordinate points are, and then we can multiply it by 2 to get our new image. So point S, make this a little bit bigger. So S, if we look at S, S is at -1, -2. Move that over. And then we're going to look at T. So T is at 0, +2. U is at +2, +2. So 2, 2. And then the last one, V is at 2, 0. Okay, so we have our points. We're going to take those points and we're going to multiply it by 2. So I'm going to change my color. Okay, so for S, we need to do -1 times 2. So -1 times 2, a negative times a positive is still going to be a negative. And then 2 times 1 is going to be 2. Now we need to do -2 times 2. So a positive times a negative is going to be a negative. And then 2 times 2 is going to be 4. Then we just go through and multiply each one by 2. So 0 times 2 is going to be 0. 2 times 2 is going to be 4. 2 times 2, again, is +4. 2 times 2 is 4. Whoops. Next one, 2 times 2 is 4. And 0 times 2 is 0. Okay, so let's go ahead and plot those points. So for S prime, I'm going to go to -2 and then to -4. So down 1, 2, 3, 4. That's going to be S prime. Then we got to go to 0. So we're at 0, and then we have to go up 4. So 1, 2, 3, 4. And that's going to be T prime. Then we need to go to 4, 4. So I'm going to go over 4, and then I'm also going to go up 4. That's going to be U prime. And then last one is V prime. Let's make that an actual U. There we go. So we have to go to 4 and then 0, and that's going to be V prime. So we've labeled it. Let's go ahead and draw some lines. All right, so we got to go from S prime to T prime, and then T prime to U prime to V prime, then V prime to S prime. And if you look at this image, it's going to be bigger than the pre-image. That's because when you have a dilation of 2, it's making it 2 times bigger. Okay. So now that we have our points, let's go ahead and plot them in, or put the points into GoFormative. So V prime, oh, it looks like it's another typo that I need to change, so I will change that. So again, it's just kind of going in order, S, T, U, and V. So V prime would be, S prime would be -2, -4. There we go. And then T prime would be 0, 4. Roll it down. Next one is going to be U prime, and that's 4, 4. Oops. There we go. And then V prime is 4, 0. Okay. Plotted all those points. Great. Let's move on to the next one. 28 says, which type of transformation is described by x, y maps to x + 5 and y - 1? So we need to figure out, okay, what does it mean when we have x + 5? And what does it mean when we have y - 1? So one way to do this is by kind of using a coordinate grid and figuring out, okay, what happens if we add 5? Do we go to the left or to the right? And what happens when we do -1? Are we going to go up or are we going to go down? So for x, again, x, you're traveling left and right. So if you add 5, it means that whatever your point is, you're going to be moving to the right. So we need to pick one that says 5 units to the right. So that means it gets rid of this option and it gets rid of this option. So now we only have like B and D. So now we need to figure out, okay, is -1 going to move us up or going to move us down? So y is up and down. If you're going to subtract 1, it means you're going to go down 1. So we need 1 unit down. So that means our answer should be this one because it says 5 units to the right and then 1 unit down. All right, next one, it says, which pair of transformations is the same as a reflection across the y-axis? So we can use the Show Your Workspace to test out the answer choices if needed. One of the pages on your resources for the practice test and the test is a page that looks like this, okay? And it has all of the notes pages where we talked about, okay, what characteristics, what properties are preserved in a reflection, what properties are preserved in a translation, what properties are preserved in a rotation. We also talked about this. These are some notes that we took, so I put them in there. And then also what properties are kept the same in a dilation. So you can use this as a resource. But I'm actually going to go through and kind of model what it would look like if you showed your work to kind of mentally figure out what the answer is. So for here, it says we need to do a rotation of 90 degrees counterclockwise and then a reflection across the x-axis. So I'm just going to draw, or I'm going to pick a point. I'm going to plot a point and then kind of model what would happen after the first transformation and what would happen after the next transformation. So let's say we have a point that's 2, 2. And if we did a rotation of 90 degrees counterclockwise, that means that we would move 90 degrees this way. And instead of 2, +2, 2, we would get -2, +2. Actually, I'm going to change the colors. And I'm going to put the same point for each one so we can practice. There we go. Okay, so if we did a rotation of 90 degrees, our new point would be here. And then we need to reflect it across the x-axis. So again, the x-axis is right here. If we're going to reflect, our new point would be -2, -2. So our final point would be here. And it's asking which pair of transformations is the same as a reflection across the y-axis. So it's asking, is this, when you go from the orange dot to the purple dot, is it the same as a reflection across the y-axis? So is it the same as the orange dot becoming the blue dot? And the answer is no, it's not the same. So this one, not going to work. Let's look at another one. Nope, I used blue. There we go. Okay, so let's do this one. A rotation of 90 degrees clockwise. Okay, remember that counterclockwise is the norm. So if we're going clockwise, it means we're going to go like rotate to the right. So our new point would be here if we rotated 90 degrees clockwise. And now it's saying a reflection across the y-axis. So instead of here, we're going to be over here. So our new point would be here. So the question is this the same as a reflection across the y-axis from orange to, it should be over here? And the answer is no, that doesn't work. Orange and purple, not going to work. Next one, it says a rotation of 180 degrees and a reflection across the y-axis. So I'm going to move it up a little bit. So our first transformation on this one is going to be a rotation of 180 degrees. So again, 180 degrees, it's kind of like you're moving along the same line. So you would line up the origin and your point and have it the same distance from there. So we would be at -2, -2. And then it's saying the next transformation is we need to do a reflection across the y-axis. So y-axis is right here, and we're going to reflect to have it over here. So let's plot that point. There we go. And is that the same as a reflection across the y-axis from our original point of orange? And the answer is no, that's not going to work. So it's definitely not that one. Let's look at the next one and see if that one works. So first transformation we need to do is a rotation of 180 degrees. So kind of similar to this one. So we're going to put our point there. We reflect 180 degrees. And then it says a reflection across the x-axis. So now we're going to take this and we're going to put our point right up here. There we go. And then the question is this the same as a rotation, or sorry, a reflection across the y-axis? Yeah, if we were to take orange and say, how would you get point purple? It would be, we could say reflection across the y-axis. So these two transformations is the same as a reflection across the y-axis. So we need to pick the one that says this. So a rotation of 180 degrees and reflection across the x-axis. Be careful because it's really easy to mix up, you know, y, the letter y looks a lot like the letter x. So just make sure you're picking the right one. So reflection across the x-axis. So the answer would be this one. So this one we can say, yes, it works. Again, you don't have to show your work for this one on the test or on the practice assignment. But if you wanted to mentally work through all of these, that would work. Again, you could also look at maybe this to see what stays the same and what changes. Let's move on to number 30. Here we are at the next one. It says triangle ABC has vertices A, B, and C. It gives us the points. It says we need to rotate triangle ABC 270 degrees and then reflect it across the y-axis. We need to graph the original points and then draw the resulted points after the two stated transformations, shade in the final transformation. So this problem is a composition, meaning you're doing two different transformations and they're in a specific order. So I'm going to click on 31, show your work. Your first step for this one should be to plot these points. So we're going to go ahead and plot those points. So A is going to be at 1, 1. So I put a little dot. B is going to be at 2, 4. So I go up here to 2 and then 4. And C is going to be at 4 and then 2. Okay. And then I'm going to use my line tool to kind of draw my lines, connect them. And then I can use the scribble tool to write down what the names are. So this is A. We said that this one was B, and this one's C. Okay, so our first transformation is we need to rotate it 270 degrees counterclockwise, because that's the default. So you can go to your resource and look up what the instructions are for rotation of 270 degrees. So I'm actually going to take this and copy and paste it into my workspace. I press text, the first one, we're going to be doing that. So that's the rotation of 270 degrees. So let's move some things over. Okay. Okay, so that's rotation of 270 degrees. I'll probably write it out. Okay. And then the next one is, it says we need to do reflection across the y-axis. So again, you can go up here, look at your instructions for reflections across the y-axis. So we're going to need to do this. So I'm going to copy that down and put it in my show your work as well. So we need to just make the X be the opposite sign. So I'm going to write reflection across y-axis. That's where we take x comma y and we change it to be negative x comma y. Also, I'm going to make this a little bit smaller. We can still use it as a reference, but that's going to be our plan of what we're going to do. So first thing is we need to take these points and we need to swap them So flip them and then change the sign on the x value. So let's go ahead and just write down these points. That way we have them. Make it a little bit smaller size. Or you could just use the points that are written here. So let's do that. So for A, again, we need to swap them. And then we need to make the sign of our x value be the opposite sign. So this one's easy because it's 1 and 1. So our A prime, meaning our rotated image, is going to be 1, -1. Okay. For B, we've got two different numbers, so we need to flip it. So it's instead of 2, 4, it's 4, 2. And then we need to make it negative, so it's going to be 4, -2. Last one for C prime. Instead of 4, 2, it's going to be 2, 4. And we're going to change that 4 to a negative, so it's going to be 2, -4. Okay, so let's go ahead and plot those points. So 1, -1. There we go. 1, then -1. And then 4. Let me make this dot a little bit bigger. There we go. Then 4, -2. So I go to 4, and then I go down 2. I'm going to have a dot there. Next one is 2, -4. And we got a dot there. Let's go ahead and use the line tool, connect the dots, make our rotated image. And there we go. So it's been rotated 270 degrees counterclockwise, and we get this. I'm also going to label my vertices. So we said that this is A prime. And then we said that 4, -2 is B prime. And then we said that this one is C prime. Okay, so we rotated our image. The next thing we need to do is we need to reflect it across the y-axis. So here's our y-axis. So we need to take this and flip it over here. So we're just going to take that x value that's right here and make it a negative number. So I'm going to change some colors. And I'm going to move it a little bit over. So instead of 1, -1, we're going to have -1, -1. Again, our y value is not changing. It's just the x value that's changing. So instead of 4, it's going to be -4, and we keep that -2 the same. And then the next one, C double prime, we make the x negative, so -2 and then -4. Whoops, there we go. Okay, so let's plot those points. We need to go to -1, -1. So there's our first point. And then I might as well just label it as we go. So that's A double prime. And then B double prime is -4, -2. So B, ooh, that's not a B. B double prime. And then C double prime is at -2, -4. So it's going to be down here. And that's not a C. Oh, it was a C. C double prime. Connect the dots, make our triangle. And there we go. Let's see, -2. Is that right? Yeah, -2, -4. And we can see that across the y-axis, it's being reflected, so it should be a mirror image. And we can see that kind of symmetry, okay? That's it for this one. We need to enter in our points into GoFormative. I know it's really tiny and really hard to see. I think it would be bigger if I took this little note and moved it over here. Let's see if that works. Yeah, it's a little bit easier to see. Okay, so A prime we decided is 1, -1. B prime we decided was 4, -2. C prime we decided was 2, -4. Now we need to type in A double prime for our final image. So we decided that was -1, -1. And then we decided to take b prime and change it to b double prime, it would be -4, -2. And then for c double prime, instead of 2, -4, it would be -2, comma, -4. -2, comma, -4. Alrighty. So that's it for that one. We showed our work. We graphed both of our transformations. We put our final points. Here's the last problem. So here we go. This one says that Jesse draws triangle ABC on a coordinate grid. The slope of the line segment AB is -2/3. I know it's kind of hard to see, but there should be a fraction there. It says Jesse then transforms triangle ABC using a single transformation to create triangle A prime, B prime, C prime. She claims that the slope of A prime, B prime will still be -2/3. So for each transformation described, indicate whether it supports or does not support Jesse's claim. So we need to figure out, when we do these transformations, does it prove that the slopes will be the same with each transformation? So this one, like number 38, it's saying, or Jesse's saying that a reflection across the y-axis means that the slopes will be the same. If it's not, then it doesn't prove her claim. So we need to show our work by completing each transformation on the grid provided. Okay, so let's click on 38. We're going to click on show your work. There we go. And it says we need to do a reflection across the x-axis. And that's a typo. I need to change it. It needs to be y-axis. So let's make sure we do y-axis. I'll change that, y-axis. So y-axis is right here. Again, we're just doing a reflection. So we've got A is here, or A prime would be there. B prime, instead of 5, 4, it would be -5, 4. So we can put B prime there. A prime could go here. And then for C prime, it would be -5, +1. Let's go ahead and draw our lines. Okay. So for this one, what Jesse is saying is that line segment AB, Jesse said that it had the slope of -2/3. Okay, and Jesse's right that, oh, hold on. Ooh, that's funky. Hold on. I'm going to pause it. I will add, so looking at the last problem, there's some typos. I will upload a video on how to do that one next. Which description of a figure and its image match the transformation described by x, y will map to 4x, 4y minus 2? For this one, it's asking you, is this new image going to be similar, congruent, and then what's happening to it? So I also uploaded another resource that's our notes that goes over when dilations are similar because they have the same angle measures and slope, or when they are not similar because they have different angle measures, slopes, and side lengths. So the difference is that an image will be similar when they have the same angle measures and slope, which means that the same thing has to happen to both x and y. So for this one, because it's being multiplied by 3 for x and y, we can say that they're similar because they have the same angle measures and slope. They're not congruent because one of the images is bigger than the other one, meaning they have a different side length, okay? So the other situation is what happens when you only change one of the variables? Or what happens when they have a different change made to them? So let's say you have an image and you're not changing the x value, all you're doing is multiplying y by 2. So when the y value changes, it means the height changes. For this one, it's not similar because they have different angle measures because we're stretching it only the y value instead of the y value and the x value. So let's go back to our problem. I accidentally clicked one of the options, so we still have to answer it. So here are options. We can say the figure and its image are congruent and the image was translated 2 units down. Well, looking at what they give us, it looks like, yes, it was translated 2 units down, but they're not congruent because the same thing doesn't happen to both of them. They don't have the same angle measures. So it's definitely not the first one. Second one says the figure and its image are similar, not congruent, and the image was translated 2 units to the left. Well, this one's not true because we know it's 2 units down, so that one's not true. The next one says the figure and its image are similar, not congruent, and the image was translated 2 units down. This one might be an option because, yes, it was translated 2 units down, and these two things, because different things are happening to x and y, they're similar and not congruent, okay? So let's just read the next one to make sure that it's not that one. The figure and its image are congruent, and the image was translated 2 units to the left. Again, that doesn't happen because it's affecting y, it's going down. And because not the same thing is happening to both of them. Again, when we're multiplying or having a dilation, meaning making it bigger or smaller, they won't be congruent. They won't have the same side lengths. So for this problem, when I looked at it, I realized that there were some typos. So what I'm going to do is I'm actually going to go over the test problem. So if you got all the way to the end, yay, you get to see me do a test problem. So I'm going to go ahead and go to the test real quick. All right, so here's the test one. It says, Jesse draws triangle ABC on a coordinate grid. The slope of the line segment, we're going to have to zoom in a little bit, is 3/4 or 3/4. It says Jesse then transforms triangle ABC using a single transformation to create triangle A prime, B prime, C prime. It says that she claims the slope of segment A prime, B prime will still be 3/4. So what Jesse's saying is that in the transformed image, the slope is preserved. So it says, for each transformation described, indicate whether it supports or does not support Jesse's claim. Show your work by completing each transformation on the coordinate grid provided. So I'm going to go ahead and click on show your work. So we need to perform the transformation that's described and then figure out, okay, is the slope preserved? Is the slope still positive 3/4, meaning rise 3, run 4. So let's go ahead and do the reflection across the x-axis. So our x-axis is right here, and we're gonna just reflect the image. When we go from the pre-image to the image, and you're reflecting across the x-axis, the only thing that's gonna change is the sign of the y value. So instead of 1 positive 1, it's gonna be 1 negative 1. So I'm gonna go ahead and plot some points. Make it a little bit bigger. So we've got 1 negative 1, and that's going to be our A prime. And then instead of 5 positive 1, it's going to be 5 negative 1 for C prime. And then for B, it's going to be 5 negative 4. So I plot those points, and then I'm going to draw my line. Remember that, so let me label our vertices. Oops. There we go. So here's A prime, there's C prime, and there's B prime. So what this person is saying, they're saying that if you look at segment AB, so it means they're looking at this thing right here, they're saying that the slope is 3/4, which it is. You rise 3, you run 4. Okay. But they're claiming that the slope of A prime B prime is the same. So we need to find the slope of A prime B prime. And you know what? I know it's not 3/4 because if a line is going downward, that means it has a negative slope. So if we calculated the slope, the rise would be -1, 2, 3, so -3 over, and it still runs 4. So these are not the same, which means that it does not support Jesse's claim. So we're going to say no, does not support the claim. Let's move on to the next transformation. 37 says we need to do a reflection across the line x equals 1. So I'm going to go ahead and grab my line tool and highlight the line x equals 1. Remember, that's where each x value is always going to be 1, or sorry, -1. So x is -1 here, x is -1 here, x is -1 here. So we've got this line that goes like this, okay? So we need to reflect according to this line. So when we go to plot our points, it means that A prime needs to be two units from this line. So we're going to do 1, 2, and then we're going to plot our A, and that's our point for A. Let's label it. I think I'm still in line tool. That's okay. So that's A prime. C prime needs to be, let's see, how many units from x equals -1. Let's count. 1, 2, 3, 4, 5, 6. So we've got 1, 2, 3, 4, 5, 6. So this is C prime. Now we need to do B prime. Again, it's the same number of units from the line x equals 1. So we need to go up 1, 2, 3. And it's the same distance from the line x equals -1, sorry. We've got B prime. Let's go ahead and draw our triangle. So using this triangle, again, we're looking at the slope of the line segment A prime, B prime, which is right here, okay? And Jesse says that if the pre-image slope is 3/4, Jesse's saying that if you reflect it across the line x equals -1, that it'll be the same. But you know what? It's not, because it's going downward. So if we were to calculate the slope, we would say, okay, how many does it rise or run? It goes down 3, so it'd be -3. How many does it go over from left to right? The answer is 4. So these two slopes are not the same. So we would say, no, it does not support Jesse's claim. Let's go to the next one. It says we need to do a translation down 5 units and left 2 units. So let's plot some points. So for A, we need to go down 5, so down 1, 2, 3, 4, 5, and left 2 units. So I'm going to go left 1, 2, and we're left with the point -1, -4. That's going to be our A prime. For this one, again, you just do the same thing. So down 5, so down 1, 2, 3, 4, 5, and then left 2, 1, 2. So that's going to be our C prime. And then B, again, down 5, 1, 2, 3, 4, 5, and then to the left 2, and that'll be our B prime. We need to connect the dots. Okay, so we did a translation. And let's go ahead and look at the slopes of A, B, and then A prime, B prime. So here's A, B. Again, Jesse claims that it is 3/4. So our question is this new image, does it have the same slope? Is it still 3/4? And yeah, the lines are going in the same direction, so it might be possible. Let's actually calculate the slope. So we go up 1, 2, 3. So it'll be positive 3 over, we go to the right, 1, 2, 3, 4. So yes, it is 3 over 4. And if you look at the resources that says the properties of transformations, you can look for each one and then look at the slopes of sides to see if it is preserved. So in reflections, yes, the slopes of sides are preserved. For this one, translation, yes, slopes of sides are preserved. For rotations, we've got some things there, okay? So let's go back to our problem. So we could say, yes, it does support Jesse's claim because the slopes are the same. Let's go to the last one, number 39. It says a rotation of 180 degrees around the origin. For this one, remember, you're lining up your point with the origin and then putting that point, or you're just changing the sign of both your x and y values. So let's go ahead and plot those points. So instead of 1, comma 1, it would be -1, comma -1, and that would be A prime. Instead of 5, comma 1, it would be -5, comma -1. So that would be our C prime. And then for B prime, instead of 5, comma 4, it would be -5, comma -4. And that's going to be our B prime. Let's connect those dots. Okay. So for this one, again, we are looking at the slope of line segment AB and A prime B prime. So the slope here is 3 over 4. And then the slope of A prime B prime, if we calculated it, it goes up 3, 1, 2, 3. And then you go to the left 4. So yes, the slope is the same. It's 3 over 4. So this one does support Jesse's claim. That's it for this problem. I know the practice test had a different one, so I'm just doing the test one. Good luck on the test. Bye.